6 years ago, I experienced a life-threatening emergency. I was having dinner with some friends, and unbeknownst to me, in that meal were some cashews. I'm severely allergic. I shortly became weak and lost consciousness and went into anaphylactic shock. Fortunately, my friends knew what was happening and knew what to do, and my friend treated me with epinephrine and saved my life. Today, I'd like to talk to you about shock and the different types of shock. Not only have I personally experienced shock myself, but I've seen it and treated it in many other people in my 10 years as a paramedic. I believe it's important for everybody from all walks of life to have a little bit of understanding of shock and the different types of shock. Who knows? You could find yourself in a situation such as my friends did, and your knowledge of shock may help you save a life. So today, I will present to you on what shock is and the 4 different types: hypovolemic, obstructive, cardiogenic, and distributive. So let's begin by defining shock. A journal titled Shock, published online by the National Library of Medicine in 2023 by Dr. Koya Hayes and Paul Major, defines shock as a condition of circulatory failure and system-wide decrease of oxygen delivery and utilization, leading to cellular death. It can further be defined as a blood pressure less than 90 systolic or a mean arterial pressure less than 65. Now that we've defined shock overall as being a failure of the delivery of oxygen to cells, let's go ahead and dive into the types of shock. The first type of shock we'll discuss is hypovolemic. Hypo refers to low, vol refers to volume, and emic is in reference to blood. So essentially, it's a low blood volume. This can happen through 2 scenarios: extreme blood loss or extreme dehydration. If we think of our bodies as a container, we need to have a certain amount of circulating volume. If we lose them through blood loss, we can squeeze the container by squeezing our blood vessels to maintain a certain level. But as blood loss continues, we can only squeeze so much, and then we enter a state of hypovolemic shock. Dr. Angelica Ballanget, in an article in Medical News Today from 2023, wrote that a doctor will diagnose hypovolemic shock at about 20% blood loss, which in the average human is about 1 liter. So now that we know about hypovolemic shock and the importance of an appropriate circulating blood volume, let's talk about what happens if the blood can't get to where it needs to go. This brings us to the second type of shock, which is called obstructive shock. In a 2018 video by the Alila Medical Media, produced by Alila Lee, doctor, titled Shock, Pathology of Different Types, described as obstructive shock as being caused by any obstruction of blood flow in any major circulatory circuit. Some examples of these are pulmonary embolism. Here we have the lungs, some major vessels in the heart. And here in the lungs is a pulmonary embolism, some form of clot or air bubble that blocks blood flow to the lungs. Now the blood has enough volume, but it's obstructed from picking up enough oxygen, thereby leading to obstructive shock. Another case is when the lung collapses in tension pneumothorax, the pressure will compress the major vessels that return blood to the heart, and it obstructs the entire circulatory system. So now that we know about volume and blood not being obstructed, let's talk about how blood gets to where it needs to go, through the organ, the heart. This brings us to a third type of shock, which is called cardiogenic. In that same 2018 Alila Medical Group video, it defined cardiogenic shock as being in any case where the heart cannot sufficiently pump enough blood to sustain oxygen demand of the body. This can happen from either a sudden heart attack or dysrhythmias. So with a heart attack, what happens to the heart wall muscle is a part of it dies or is weakened, thereby decreasing the heart's efficiency to output blood to meet the oxygen demand. In dysrhythmias, the heart rhythm can either go too fast or too slow. If it goes too fast, it can't fill efficiently, like a pump not being primed, and therefore you have decreased oxygen delivery. If it goes too slow, that's pretty self-explanatory. That's cardiogenic shock. So now the past 3 types of shock we've talked about all deal with the cardiovascular system. Let's look at a type of shock that isn't directly caused by the cardiovascular system, which is our 4th type of shock, called distributive shock. In the previously mentioned 2023 journal Shock by Dr. Koya Hayes and Dr. Paul Major, they described distributive shock as being the most common type of shock. there's 3 subtypes of distributive: sepsis, anaphylaxis, and neurogenic. In sepsis, you have a system-wide infection, which causes a massive inflammatory response. And within that inflammatory response, it actually damages blood vessels, allowing them to leak, mimicking hypovolemic shock. You have enough volume, but it's leaking out of the vessels. In anaphylactic shock, what happened to me, somebody has a severe allergic reaction and there's a systemic-wide release of histamine. A side effect of wide release of histamine closes your airways as well as dilate blood vessels. So we go to having a container that's full to a bigger container that can no longer be full with that circulating volume and you enter shock. In neurogenic shock, damage happens to either the brain or the spinal cord, and think of it as like cutting the wire that's controlling the circulatory system. Now the system that's regulating your blood pressure can no longer be regulated, and you can enter into a state of shock. In conclusion, we've defined shock as a life-threatening state of deficient oxygen delivery through a failure of the circulatory system, and comes in 4 types: hypovolemic, obstructive, cardiogenic, and neurogenic. I hope you found the information presented today useful and interesting, and I encourage you to learn more on this broad topic. Who knows, what you've learned today, or what you continue to learn, may help save a life as it did mine. Thank you.
Yay!
Yeah!
I think that